Okay, everyone, so make sure you're paying attention. I'm going to go through it kind of fast, but we're going to go through a lot of the questions. This was your Unit 7 exam. I want you to do the same thing with all of your exams. I think that's where you should start. When you're reviewing for your final, I would really go through every single one of your unit exams and start studying there. Then start doing more practice problems, looking at worksheets, things that, worksheets and labs and things like that. But the unit exams are probably where you should start. So something you should probably write down for all of these problems are the equations. A lot of the equations are on your equation sheet. Here are the ones that are on your equation sheet. So pH plus pOH. This is the whole acids and base lesson. pH plus pOH equals 14. They always equals 14, okay? So if you have the pH, you can just subtract from 14 and get pOH. They always add up to 14, right? Both of those. The other equations that you find on your equation sheet is pH is equal to negative log of the H plus concentration. And the pOH is equal to negative log of the OH minus concentration. These three are on your equation sheet, okay? Some other ones that are on your equation sheet, which I'll write in pink here, that you didn't really use that much, but it's the KW equation. And that's the H plus multiplied by OH minus concentration is always equal to a constant. It's the constant 1 times 10 to the negative 14. 1 times 10 to the negative 14. Now I wrote it in pink because you can use it. You don't have to use it, but you could use that. Like, in other words, if you have H plus and they want you to solve for OH minus, you can plug it in right there and solve for OH minus. Yeah, this is like a shortcut way. So this is viable, okay? It's always equal to 1 times 10 to the negative 14 power. Okay, two of the equations that they don't mention in your equation sheet is pretty much these two equations flipped around, like the anti-log of both of these. So what you do is this. If you're looking for H plus, maybe I'll put it on the whiteboard for you, okay? But it would be nice for you to just memorize these two. H plus is equal to 10 to the negative pH power. And OH minus is equal to 10 to the negative pOH power. Okay, those bottom two are not on your equation sheet, but maybe I'll write it on the whiteboard, okay, during your final. Remind me if it's not up there or, but, try to remember these two. Okay, y'all write this down. I'm gonna erase this in a moment. Okay, I'll just leave that up just for right now because some of you are still writing it down. Let's look at number 1. Okay? At 25 degrees Celsius, a solution has this much OH minus. It says calculate the pH. Okay, how do you do it? So what I would do is this. They give me OH minus. What I can do is I can plug that right into here and I can get pOH. Once I get pOH, I can subtract from 14, and that's pH. All right, so everyone get your calculators out. Make sure you can plug this in properly. So negative log 2.90 times 10 to the negative 2 power. If I plug it in right there, I'm getting 1.54. But right now, this is what's called the pOH, and my problem asks for the pH. This is why this test was a little bit tricky, because look at 1.54. If you stopped right there, you have an answer choice that says 1.54. So some of you were like, oh, I'm done, like I got this. I plugged it in, negative log, and then you stopped there, and then you answered E, and the choice is there, but it's not the right answer. That's the pOH. They asked for the pH. You have to look to see what they're asking for. So 14 minus 1.54. You just always subtract from 14 to get the pH. Or if they give you the pH, do the same thing and that'll give you the pOH. So 14 minus the answer, and the answer rounded and everything is 12.5. Okay, I'm going to move a little bit faster, so follow here. Number 2. It says calculate H plus. They gave me pH. H plus is equal to 10 to the negative pH power. That's just an equation that you have. So all you have to do is 10 to the negative 8.38 power. And that's the answer, okay? So plug it into your calculator. Make sure you know how to plug it in and everything so that you're doing it right. On my calculator, sadly, it says this, 0.0. So some of you might have got this wrong because of this. But on my calculator, it says 0.0000000 8 zeros and a 4 after the decimal point. And that's why some of you might have got this wrong. But let me show you how it's done. All of these are shown in scientific notation. And so the key is, since these are in scientific notation, you just have to figure out how many decimal points, how many spots did the decimal point move. So check this out. 1, 2, 3, 4. You see how all of the decimal points are after the first number? The decimal point is here, 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 here. You have to move the decimal point there after the 4. So we'll start again. 1, 2, 3, 4, 5, 6, 7, 8, 9 times. It went 9 times. And this is a really small number. So it's kind of like 4 times 10 to the negative 9th power. That's how you change it to scientific notation. The only answer that's close enough is C. All the other ones, they don't even have like this one has a positive 8, positive 2. Positive exponents make the number large, like 200, 5 million, 50 million. Okay, that's what happens when you have a positive exponent. So these two are out of the question, okay? And then this one is really close, but you're looking at the minus 9 one, okay?
Can I go to a health office? This is really bad.
Yeah. Any questions about this one? No problem, right? We're going to move forward. This is how you had to figure this one out. I know I'm going to try to stay away from like scientific notation, because if you messed up because you didn't know scientific notation, that kind of sucks. I wanted to know whether you knew how to plug in 10 to the negative pH power. My calculator showed me this number. Maybe your calculator gave you something closer to this. I don't know. But if it does give you that, don't worry, just move the decimal point slowly until you reach after the 4, until you reach after the number. And then the number you counted, that's going to be, if it's a small number, that's going to be negative exponent, -9. Okay. So moving right along, let's look at number 3. Here's a bit trickier. Now, how to do this, okay? Now look. We have NaOH. And what you need to recognize is that NaOH, is it going to give H plus or is it going to give OH minus? Remember, this whole exam was about H plus and OH minus. You see the OH here, right? Because it has OH, it's OH minus. So the molarity that you see here, the 0.00175 molarity, now I want to make a note. When it's NaOH, it's going to be Na plus and OH minus. For one of these, you get one of these and one of these. But what if you had something like this, CaOH2? This is a much trickier question, but I didn't put it on this test, but maybe on the final. It's going to get Ca2 plus, but I want you to notice this. You see how there's a 2 here for OH? You see how there's a 2 outside the OH? That's going to actually make 2 OH minuses. So really tricky for one of these, right? You get one of these, but you get 2 of these. So for this one, 0.00175, because it's just 111, because it's 111, it's no problem. It's gonna make the same 0.0175 plus 0.00175 of this. This is therefore the OH minus. So whatever they give you this, that is the OH minus because there's one OH. Now look, if this was CaOH2, if it was 2, you need to multiply this by 2, okay? And that'll give you the OH. You have to multiply by 2. What if they gave you something like this, AlOH3? What do you need to do with this original number? You got to multiply by 3 to get the OH minus. Now, how do you calculate pH? You have to negative log the OH minus to get pOH and subtract from 14. Now, if all of this confused you, don't be confused. Let's just focus on this question for right now. NaOH. NaOH, how many OHs are in NaOH? 1. So this number, you don't do anything. You don't have to multiply by 2. You don't have to multiply by 3. Because it's just 1 OH. So this number that they gave you is the OH minus, okay? Is the OH minus. So what I do is I would solve for pOH first, which is negative log of OH minus. So calculate in your calculator negative log 0.00175. That's 2.76. Look at that. Trickery again. Look at the answer choices. The answer choices, 2.76 is there, but it's not the answer. Because this is pOH right now. So don't ever just stop in the middle. Just make sure you know what you're looking at. They want the pH. So remember, pH plus pOH is always 14. So always just, 14 minus this is going to be the pH. So 14 minus 2.76 That looks to be like 11.24, something like that. 11.2. And so this is probably your answer. D. Again, this is being recorded, so you can play it, you can watch it at home. You can also pause it. You can rewind it, anything that you're missing. Okay, should we move on?
1 second.
Yeah. So these were the first 3 questions of your Unit 7 test. We'll do the same thing next class for Unit 8. Unit 9, I'm really not going to review. We just took the test on Unit 9. But that stuff is going to be on the final again. Unit 8 was stoichiometry, which was pretty challenging, so I want to spend a whole period on that. And then Wednesday, we can do anything you want. We can go back to gas laws. So after this, right? After this hour, for the next hour, I want you to keep studying this if you want, or go back to Unit 6 exam and do the same thing I'm doing on your own. Unit 6. Okay, so let's move on. I'm going to skip number 4. I'm going to assume you can do this one. Think about what you need to do. They give you OH minus. They gave you OH minus. They want pH. You know what to do? You can negative log, right? Negative log the OH minus. That gives you pOH. What do you do with pOH to get pH? Subtract from 14. So negative log this gives you pOH. And then subtract from 14. Right? It's the same thing as here. It's the same thing as number 3, except number 3, this is the OH minus. This time, this is the OH minus. Negative log it, that's the pOH. Subtract from 14, that's the pH. Okay? This is just as simple also, right? This test was very doable. This is H plus. They want pH. What do you need to do that number? pH is negative log of H plus. So all you have to do is negative log that number, and that's the pH, and you're done with this problem. Right? Negative log of 3.98 times 10 to the negative 9, and that's the pH. So negative log 3.98 times 10 to the negative 9, and I got 8.400. Okay? A lot of this test was just this. Literally, like using those equations I gave you and just plugging it in your calculator and just making sure you're just plugging it in correctly, and that's it. At least half of this test seems to be this way. Okay? All right, number 6. What is the concentration of hydronium ions? So maybe you didn't know what that meant, but hydronium ions is this, and H plus, and concentration is the bracket. So they want this, and they give you pH. So remember that one equation? There's an equation for this too. H plus is 10 to the negative pH power. So you're going to go 10 to the negative 4.282 power, and you're done. Right? This was the equation, right? This was the equation. And you plug in 10 to the negative 4.282. And my calculator gives me 0.000052239. Now that we did the whole thing of the, you know how we did scientific notation last time? Can you figure out what answer choice this might be referring to? A, B, C, or D, or E? It's E, right? I mean, first of all, it's got to have like 5, 2, 2. And then, it's negative 5 exponent. If you look, it's negative 5 exponent. So it's 1, 2, 3, 4, 5. It's a small number. So times 10 to the negative 5 power. I mean, the other answer choices aren't even close. So, I mean, you have to look at that also, right? It's a small number. It needs to be a negative exponent. This is out. This is not the number. That is not the number. So it's between B and E. And, I mean, you only have to move the decimal point 5 times. So it's E. Okay. All right, so that's number 6. Number 7. There are several ways you can do number 7. You can do it conceptually by really thinking carefully, or you can actually calculate. Which solution do you think has the most H plus? Hydronium ions are the stuff that stings you. It's the stuff from acids. So which pH? Remember, anything under 7 pH is what? An acid. Above a 7 is what? Alkaline, or another word? Base. Right at 7, as you were mentioning right now, is neutral. Very good. So under 7, so which one has the highest concentration of hydronium ions? Which one's going to be so H plus concentrated? And H plus is what makes it acidic. It's what stings your tongue when you eat vinegar. Or it's what stings, what will sting your fingers if you... Or even when you eat an orange or a lime, you know how it stings your lips? That's the H plus stinging your lips. And that's because a lot of H plus. So what pH would have a highest concentration? A. Okay? So it's as simple as 3.21 there, and you're done. The other ones are all like, this is a base, that's a base, that's a base, and that's neutral. Right? B is a base, C is a base, D is a base, E is neutral. Okay, number 8 was naming acids. Do you want to go over that? We have HMNO4. You know what you have to find? You have to find where this is on the polyatomic ion chart. Polyatomic ion chart. And I'll tell you what it is, but you know how you have access to this during the final and all on the test? You have access to the polyatomic ion chart. This right here you find on that chart, and this is called permanganate. What do you do with 8? what happens? What did you eat? You ate what?
Something icky.
Something icky. Very nice. You ate something icky. So 8 turns into ick when it becomes an acid. So permanganate, which this is, but now it's an acid because of the H. The H is what makes it an acid, right? So now it's an acid. So the name of this is the 8 turns into ick. So the final answer is permanganic acid. Permanganic acid. Yes.
When would you put the hydro? Is that when there's no oxygen?
Very good question. Yeah. You would use hydro. So the question was, when do you use hydro? And you're going to use hydro, like for this one, for this problem here, you're going to use hydro when there's no oxygen. When there's no oxygen. Yeah, for example, like HCl, HBr, HF, HI. These are like H2S. These are some like, I mean, those are pretty much your only choices really, right there. You won't really find anything else besides, maybe HCN. Anytime there's no oxygen. And there isn't that many. It's just this group right here. Everything else that has oxygen, you have to find the polyatomic ion on the polyatomic ion chart. And if it's ITE, it turns into OUS. Sprite is delicious. ITE turns into OUS. And you ate something icky, so ATE turns into IC. All right. You're not going to get too many of those, I don't think, but just in case. Ooh. So you guys had to learn this too? Weak acids, Ka. Do you remember? We learned it. I only gave you like one question on this test, I think. 1 or 2 maybe max. Remember this equation? Ka is equal to, and this is like the shortcut. There's a reason why it's x squared. There's a reason why, but I taught you just to do this. And I told you that you can pretty much always ignore this minus x. And so that is your equation. This is like that ultimate equation you're like using, you know? So you pretty much use this equation over and over to find whenever you have a weak acid. So anytime they talk about Ka, you're using this. But this equation also is not on your equation sheet, and it's not something I give you. Because you should be able to derive this from using Icebox. But that gets a little crazy. So, anyways, the Ka, they gave you the Ka, so it's 3.0 times 10 to the negative 8 is equal to x squared. They want to know the pH, by the way. It says, what is the pH? And they gave you the molarity, it's 0.020. And I'm going to ignore that minus x in the denominator, even though it exists. Then you solve for x. Do you know how to do that? You have to multiply this to the other side. Like both sides, right? But this right side is going to cancel out. And then you have to square root it to get rid of the square. To get rid of this, you have to square root this whole thing. Both sides. You have to square root both sides. When you square root a square, it gets rid of the square. And you're left with just x. So 0.020 times 3 times 10 to the negative 8 power. And then square root that answer. And I got x equals 0.000024494. This was the hardest problem on the test. But that's what x is. Now, what you have to figure out is x, what x is. X ends up being your h plus, okay? X is h plus. X is h plus. So what do you have to do with the h plus? They want pH. So can you get pH from H plus? What's the equation? Negative log, right? Remember, pH is equal to negative log of H plus. So negative log of H plus. And I got 4.61. This is the hardest problem of the test. All you have to remember is that equation that's in gold. Ka is equal to x squared over m. They give you m, and they give you Ka. So you have to solve for x, and then negative log the x. And that's the pH. X is H plus. X is H plus. Okay? Again, if you miss anything, just watch the video and you can fast forward to it and pause, things like that. Okay, so let's see what else is there. The conjugate acid. Should we go over this? Do you remember this? The conjugate acid of this means that this is going to act like a base. The conjugate acid of this means that this is going to act like a base. This is the crucial thought. And what do bases do? Well, acids donate H plus. Bases accept an H plus. So this is the very important thing to realize. Bases accept H plus. So the conjugate acid, if they're looking for the conjugate acid, this is going to act like a base. It's the opposite. And what do bases do? They accept H plus. So what is this going to look like if it pulled in an H plus? What is it going to look like? It's going to have two H's now. So it's either D or E now already. You already knocked these three out. It's going to have two H's because it's going to pull in an H. And the pO4, it was a -2, but you're taking in an H plus, an H and a plus. So a -2 is going to end up being -1. Negative 2 is going to turn into negative 1. This thing an H plus is joining. An H plus is joining. So you're going to get another H, and then the negative 2 is going to become negative 1 because of the plus. It's joining. Let's throw. What if I threw in like. Let me just tweak this question. Instead of conjugate acid, what if it said I want the conjugate base of this? If I want the conjugate base, that is going to act like an acid. It's going to act like an acid. What did I say acids do? They give. They donate an H plus. So if you're sitting like this, and an H plus is going to pop off you. You're sitting like this, but an H plus is going to pop off. What are you going to turn into? You're going to lose the H, right? So it's going to be PO4. And you're going to lose another positive. So now it's not negative 2, but you're gonna lose a positive, which means you're gonna become more negative. It's gonna be negative 3. Choice B. Okay, that's if I change that acid word to base. Okay? Looking back, I can see how challenging this test must have been. But most of it was pretty straightforward. It was just like this. Like number 11 is kind of like the ones from number 2, 3, and 4. You just plug into the equations and find the answer. What about 12? Laundry detergent. What's the pH? It's slippery. Hint, it's slippery. Which one would you choose? 12. Remember, like cleaning supplies are alkaline. They're very high in pH, okay? So the highest one here is 12. The other ones are like, there's 3 acids here and a neutral. So, all right. Now, how do you do number 13? Remember how earlier there was a problem that had NaOH? And whatever number they gave you, that was the OH minus. This time, there is no NaOH, but there is an H. So you know what this number is? That is the H plus. On that last problem, if it was OH minus, it becomes the OH minus. But this time it's H plus. So do you know what to do with that to get the pH? Negative log. Very nice, Bronson. Negative log of 0.10. and you get pH of 1. Okay? So in a problem like this, just look to see what you have. Like, just look at this. Look at this. And you're like, oh, they gave me H. That's H plus. This number is H plus. If they give you OH, if they give you NaOH or whatever, this number is OH minus. But remember, if they give you something like this, with a 2 outside, you have to multiply that number by 2. And then that's the OH minus. What if this one, they gave you H2SO4? That's 2 H's. You have to multiply this number by 2, and then that's the H plus. I'm going to try to stay away from being tricky like that, because as you can see on this test, there was nothing like that. There's just been HNO3, which is 1H, and the other problem that we had that saw something like this was just straight up NaOH, which was 1OH. But if you see H2SO4 here, you have to multiply that number by 2, and that's the H plus. Okay, acids taste sour, acids make litmus paper turn red, bases feel slippery, right? Bases react with acids to produce salt and water because they neutralize each other. And when they neutralize, you make salt water, which is pretty nice. Number 18, pH of 8 is a base because it's over 7. Number 19, a solution with a pH of 5 is not basic, so you can knock A out. It's not neutral, you can knock C out. They give you hydrogen ion concentration, that's H plus. This is OH minus. So what I would do is quickly calculate if this is H plus 5, I can negative log this to get the pH. And it comes out like negative 0.69897. That is not 5. So I'm assuming D is your answer. If you want, hydroxide, by the way, everyone, is OH minus. Hydrogen ion or hydronium is H plus. So if you negative log this, number, you're gonna get 9. But that's the pOH. And then 14 minus 9, that's 5. And pH is 5. So D is the correct answer. Sorry about the typo here or the formatting. Whenever you see a number like this, I hope you know that that's supposed to be exponent, right? The negative 9 should be exponent. Superscripted. Okay. That was pretty much the test. I'm going to stop it here. I'm going to stop recording here.